As we take a look here in section 7, the title of the section is Solve Right Triangles, and the reason it's called that is simply because in today's section we're going to look at this idea of inverse trig functions that will allow you to solve for angle measures now within a triangle, and so a right triangle I should say. And so at the end of today's video I could give you any right triangle and give you minimal information, and you should be able to use the right triangle trig that we've discussed to solve for everything and anything in the diagram, any angle, any side, and then and again, as we look at some examples, hopefully this stuff starts to make a little bit more sense to you. So this is not what I wanted. There we go. Okay, so inverse trig functions, find the angle. Okay, and so you'll notice here it says if the sine of A equals A over C, then the inverse sine of A over C equals the measure of angle A, and then the other two boxes say the same thing. The way I've always explained it is I tell you this. When you set up this equation, okay, if you know that we want to know this angle measure, then you set up the equation, and then what I tell everybody is the way that you get rid of this sine is you take the inverse sine of both sides. Okay, inverse functions cancel each other out. So if you have sine and inverse sine on the same side, they're going to take care of each other. They're going to cancel each other out. Okay, so example 1 here says let angle A and angle B be acute angles in two right triangles. Use a calculator to approximate the measures of angle A and angle B to the nearest tenth of a degree. So really all you need to recognize here is if I know that the sine of A equals that, then to get A by itself here I got to take the inverse sine of both sides. By the way, when you do the inverse sine it always goes out in front. And so inverse sine and sine take care of each other, and so A equals the inverse sine of 0.7624, and now you just plug that into a calculator. Okay, if you have a graphing calculator it's a little bit easier, although some scientifics are just as easy as well. So on a graphing you would hit second sine 0.7624, hit enter, and you get 49.7 degrees. Okay. Part B, you should be able to do that one now. Go ahead and try Part B on your own and C, and kind of see where you're at with this stuff. If you have questions on B and C, obviously ask me in class, but hopefully that first example kind of shows you what you're going to do. Okay, example 2 says use your calculator to find each angle measure to the nearest tenth. I'm not going to go through this. This is just so that you can get comfortable with your calculator, finding where the inverse cosine is, finding where the inverse sine is, finding where inverse tangent is on the calculator. Example 3 is where we're going to start getting into some stuff that we'll actually be doing quite a bit of. Okay, and that is example 3 says use a calculator to approximate the measure of angle A and angle C to the nearest tenth of a degree. Okay, so let's just say we want to find angle A first. Okay, well again, here's the angle I'm using. And so now you identify what pieces of information you're going to work with. Well, I'm working with 16, which is the opposite side, and 20, which is the adjacent side. Opposite adjacent tells me to use tangent. So here's what I know. I know that the tangent of angle A is equal to 16 over 20. If you want to go one more step to simplify 16 over 20, you can, but you don't need to. Again, I'm trying to solve for A, so that tells me to take the inverse tangent of both sides. So those cancel, and so what you're left with now is A equals the inverse tangent of 16 over 20, or you could say 4 over 5. Doesn't matter, either way. Okay, and so now you just go to your calculator. Second tangent, 4 over 5 equals, so A is approximately, and it says what's the nearest tenth, so 38.7 degrees. Once we know angle A is roughly 38.7, then angle B is pretty easy to find because we know the angles in a right triangle, or any triangle for that matter, must add up to 180. So I'm going to go ahead and do 90 plus 38.7 equals, and then subtract that number from 180, and I get the measure of angle B to be roughly 51.3 degrees. Okay. I'm sorry, not angle B. It should be angle C. My apologies. Angle B is the right angle, obviously. Okay. All right, example 4, again, at this point, if you feel confident, I would probably start pausing the video, try to work through the next few examples on your own. If you want to watch part A, that's fine, just to get some guidance here. So it says find angle A. So I know I'm working with this angle. I know 12 is the opposite, 14 is the adjacent. Opposite adjacent, again, just like the previous screen, we're going to use tangent of A equals 12 over 14. Okay, want to get rid of tangent, so I take the inverse tangent of both sides. And so when I do that, they cancel, so A is equal to tangent, inverse tangent of 6 over 7. And so then again, you go to your calculator, inverse tan 6 over 7 equals, so A is roughly 40.6 degrees. All right. I'll take a look here at part B as well. So again, we're still trying to find angle A. So now what you have is you have the adjacent side and the hypotenuse that you're using. If you're using adjacent hypotenuse, that tells you to use cosine. So cosine of A equals adjacent over hypotenuse. Again, we're back to square one. I got to get rid of cosine. So now I do the inverse cosine of both sides. Cancel, cancel. So angle A equals the inverse cosine of 14 over 25. And that's roughly, second cosine, 14 divided by 25 equals 55.9 degrees for angle A there in part B. Again, part C I'm going to let you guys take a look at here on your own. Okay, so example 5 says solve the right triangle, find BC and AC round decimal answers to the nearest tenth. When it says solve the right triangle, that means find every missing piece. Okay, and so the first thing I would do, I always try to do what's easiest first. I think the easiest thing here is to find the measure of angle B, because all I have to do is 90 plus 23, and then subtract that from 180, and I get 67 degrees. All right, so I've done that much. Now let's go ahead and call the other missing pieces. We'll just call it X and Y. I'll label this in black because we'll do that work in black. Okay, and so I'm going to scroll up here. So our task is really solve for X, solve for Y. Okay, so if I'm solving for BC, okay, it doesn't matter what angle you want to use. You can use the 23 or the 67. I'll just use the 23 just because that's what they gave me. I'll keep it simple. So X or BC is the opposite. I know the hypotenuse. So OH tells me to use sine. So sine of 23 equals opposite over hypotenuse. I just put it over 1, cross multiply. X equals 40 times the sine of 23 degrees. And so now you just go to your calculator. 40 times sine 23. Again, make sure your calculator's in degree mode. You would have realized that by now in the video if your answers were all off. So X is roughly 15.6 feet. Okay. And now I got to find Y. Okay. For Y, again, let's use the 23 again. So Y is the adjacent side, and I know the hypotenuse. Adjacent hypotenuse tells you to use the cosine. So cosine 23 equals adjacent over hypotenuse. Again, put it over 1, cross multiply. Y equals 40 times cosine 23. And finally, 40 times cos 23 equals 36.8 feet. Okay, and so that we've solved it. We know every missing piece now in that triangle. Example 6 says you are building a track for a model train. You want the track to incline from the first level to the level 4 inches higher in 96 inches. Is the angle of elevation less than 3 degrees? Okay, so the wording of that problem is a little bit confusing because it's kind of interesting. You go from first level to second level. Okay, this should be second level. That's why I was confused there. Doesn't make a whole lot of sense to say from the first level to the level. Okay, so it's 4 inches. So here's your diagram. Really, essentially, all you needed, you didn't even need to read the problem. All you have to do is look at this, and the question is X less than 3? So let's find what x is. We can solve for x now. So we're working with this angle. I know the opposite and I know the adjacent. Opposite adjacent tells you to use tangent. Tangent of x equals 4 over 96. Again, I got to get rid of the tan. So I do the inverse tangent of both sides. So those cancel. And so finally what you're left with is x equals the inverse tangent of 4 over 96. And then you just plug that into your calculator. Second tangent, 4 over 96 equals. So x is roughly 2.4 degrees. And so to answer the question, the answer is yes, it's less than 3 degrees. Example 7 says a ladder leans against a building. Ladder problems are going to be very common in this right triangle trig stuff. So a ladder leans against a building. The foot of the ladder is 6 feet from the building, and the ladder reaches a height of 14 feet on the building. To the nearest degree, find the angle that the ladder makes with the ground. Okay. So there it is right there. Call it x. Okay, let me move this up a little bit. So what do I know? I know the opposite. I know the adjacent. Okay, opposite adjacent again. That's tangent. So tangent of x equals 14 over 6. Inverse tan both sides. So tan negative 1. Tan negative 1. Cancel, cancel. X equals inverse tan of 14 over 6. Again, you could reduce it if you want. No need to, though. Second tangent, 14 divided by 6 equals x is roughly 66.8 degrees. All right. Okay, so clearly that wraps us up here. So as always, any questions you have, bring them to class. Hopefully this inverse stuff makes some sense to you. A lot of it's very similar. The nice thing about it is the setup is identical to what we've been doing. The only difference is now we're solving for angles instead of side lengths. So again, any questions, have them ready to go.